Okay, so right now, the single USB-C port on your laptop is, well, it's basically an invisible high-speed traffic jam waiting to happen.
Oh, absolutely.
I mean, it is simultaneously pushing millions of pixels, gigabits of internet, and like 100 watts of power
Yep.
all at once. So today we are doing a deep dive into the source material from HDTV Supply to really decode how we manage that massive data flow.
Right. Because the sheer volume of data we expect a single cable to handle now is just, it's staggering.
Yeah,
It requires a completely different architectural approach to signal routing than we used even, 5 years ago.
exactly. And we're tracking this from a single home desk all the way up to a 16-screen sports bar. So let's unpack this starting at the desk. The specs highlight the Intelix TU-350DOC TeamUp plus triple screen dock.
Ah, yeah, the TeamUp Plus. That one is fascinating.
Right, because for about $300, it consolidates that entire rat's nest of cables. You know, the
Yeah.
100-watt power delivery, gigabit Ethernet, all your peripherals. It puts them into just one USB-C connection. It even has this removable pivoting stand for vertical or horizontal placement.
Which is a really nice physical touch, definitely.
Yeah, but mechanically, I am looking at the DPMST feature. It is pushing up to 4K resolution across two HDMI ports and a display port. Wait, how is it not entirely bottlenecking the USB bus?
That is a great question.
Like, are we sacrificing refresh rates and dropping to 30 hertz just to keep the lights on?
Well, no. And that is the beauty of how DisplayPort multi-stream transport allocates bandwidth here. It doesn't just brute force three separate uncompressed video feeds down the pipe.
Oh, so it compresses them.
It dynamically packets the video data, so it effectively multiplexes the streams. The Intelix dock prioritizes the bandwidth allocation on the fly.
Okay.
This ensures you can extend to 3 distinct 4K workspaces without, choking the data bus or lagging out your keyboard.
Okay, so it's treating the video less like a continuous electrical current and more like routed network traffic.
Exactly. It's smart routing.
But that brings up a massive physical limitation.
Yeah.
I mean, it is one thing to dynamically route 3 4K streams 2 feet across a desk over USB-C.
Sure.
When you need to push that same massive data load, say 450 feet across a sports bar, standard copper HDMI cables completely fail, right? The signal just degrades to zero.
Yeah, they basically drop dead. Once you hit that distance, the architecture has to completely shift away from traditional baseband transmission.
Right.
And that is where we scale up to the Wolfpack fixed HDMI matrix switchers.
But wait, isn't a matrix just a glorified giant HDMI splitter?
Well, no, that is actually a common misconception. A splitter just mirrors one source to multiple screens. A matrix independently routes any source to any output.
Oh, gotcha.
So a sports bar with an 8x8 matrix can show 8 completely different games on 8 different TVs simultaneously.
Okay, wow. That makes sense.
And these single chassis commercial units, they range from a 4x2 configuration up to a massive 16x32 system.
That's huge.
Yeah. And to bridge that 450-foot gap, they convert the raw 4K video signal into packetized data that just runs over standard CT6 Ethernet cables.
So we are essentially turning a visual medium into IT infrastructure.
Pretty much, yeah.
But if you have a 16x32 grid, meaning any of 16 cable boxes routing to any of 32 screens independently, latency has to be an absolute nightmare.
You'd think so, right?
Yeah, I mean, if a sports bar shows a touchdown on one screen but the audio hits the speakers a half-second later, the crowd is going to riot. How does the Matrix decouple all that data without completely losing sync?
Think of it like a high-speed digital rail yard. It dynamically decouples the cargo, so the audio and video feeds and snaps them onto entirely different tracks simultaneously without ever stopping the train.
That sounds incredibly complex.
It is under the hood. The internal backplane of the Wolfpack Matrix has enough processing overhead to lock the ED handshakes and maintain frame-accurate sync across every single output.
Wow.
And that happens regardless of how you matrix the inputs.
Managing that rail yard from the floor sounds impossible for a bartender, though.
Yeah.
I mean, you can't be fiddling with a metal box in a server rack when 80 people are screaming to change the channel.
Exactly, and that is why the control layer is so critical to these builds. You aren't touching the physical box.
Right.
These systems integrate natively with complex commercial automation, like Crestron, via RS-232 serial control.
Okay, so it's fully automated.
Or, for a more lightweight approach, they use web GUIs and free iOS and Android apps. You were basically orchestrating that massive synchronized data flow over Wi-Fi from a tablet while just walking the room.
Wow, that is wild. So whether you are optimizing your personal workstation with a single cable Intelix dock, or wiring a commercial venue with a massive Wolfpack matrix, the core mission is achieving seamless, frictionless control over your digital environment.
Yeah, we have effectively mastered the ability to move millions of pixels around instantly, flexibly, and affordably. We are treating them just like any other data packet now.
Which leaves me with a thought for you to chew on. We have solved the hardware bottleneck. But as 4K, multi-screen matrix setups become incredibly cheap and ubiquitous in our public spaces and homes, how will our brains evolve?
Oh, that's a good point.
Right. How do we process a world where 16 different high-definition video feeds are constantly competing for our attention? We've upgraded the cables, but our cognitive bandwidth is still running on legacy hardware.